be proper because it kind of implies that one of the measurements is wrong. It's correct in its reference frame, but so if you see the thing moving with respect to you, the thing that you're measuring, the ruler that you're measuring, then you do not measure its proper length, right? So if we were talking about the length of this pen, who gets to measure the length of this pen? The proper length.
You.
I do. Why?
You hold it.
Because its front and back ends are not moving with respect to me.
Yeah.
But with respect to you guys, it is moving. Yeah?
Yeah.
Okay. What about Alexis's desk? Who gets to measure the proper length of Alexis's desk?
Alexis.
Any of you can, right?
Yeah.
Except for me,
Except for you.
right?
Oh, you got
Does that make sense?
Yeah.
No, it doesn't make
Relative
sense.
to all of us,
So-
it's not moving.
so you
To you,
mean-
it is moving.
So you mean if we didn't see the location changing, so we are in the proper length, right?
So most of the time, we are going to assume that Earth is at rest. It isn't, but otherwise, there'd be very few interesting problems we could solve. So let's assume that you guys are on Earth, and I am traveling. What's the closest star to us? The Sun. What's the second closest star to us?
I don't know.
Proxima Centauri. Proximity, right? Proximity. I think it's B. Proxima Centauri B. So let's assume that I am looking for a germaphobe's paradise, a totally unincorporated planet of my own. Le Petit Prince, anyone? Little Prince? But I leave. So as measured, the distance from Earth to Proxima Centauri is about 4.2 light years. That's our measurement, assuming Earth is kind of stationary. As I am traveling at a fair fraction of the speed of light towards Proxima Centauri, do I measure that length as 4.2 light years?
No.
Do I measure it as more or less?
Less.
I measure it as less.
So slow.
Yeah? Does that work? So, in that case, am I the L or the L? Am I measuring the L or the LP?
Yeah.
I'm measuring the L, right? Does that make sense?
Quick question, like if we were to do an analogy about light year,
What a light year is?
like
So-
an analogy, what would that be? I mean,
So, how, I think I'm standing under it. How fast does light travel?
300 million meters per second.
300 million meters per second, 186,000 miles per second. So, so anyone know about how far the sun is from us?
I don't know. I don't care.
Oh, the sun cares about you.
9?
It actually doesn't.
9 million miles?
It's inanimate.
9 billion miles?
Something like 1.5 times 10 to the 11, something like this. I can sort this out even quicker. 1.5 exponent 11 divided by 3 x 8. Yeah, that's about right. So it's about 1.5 times 10 to the 11 meters away from us. So how long does it take for light from the sun to take, how much time does it take for light to travel to us from the sun?
Around 8 minutes.
About, yeah, somewhere just under 8 1/3 minutes, right? So that is traveling 186,000 or 300 million meters every second of every minute for 8 minutes. When I say a light year, what I'm saying is if you could travel, or light does travel, 300 million meters per second for every second of every minute of every hour of every day for 1 year. So if you wanted to put this into meter terms, we'd say a light year is 3 times 10 to the 8 meters per second times 1 year times 365 and a quarter days per year times 24 hours per day times 60 minutes per hour times 60 seconds per minute. And we get year cancels year, days cancel days, hours cancel hours, minutes cancel minutes, seconds cancel seconds, and we're left with just some number of meters, which is somewhere on the order of about 9.47 times 10 to the 15 meters.
That's definitely a big number,
It is.
hard to conceptualize, right? 'Cause,
Sure.
like, we're talking about to the sun, it's 8 minutes, and it's a huge distance, but like, as an analogy, what would that be if we were to make an analogy hitting the planets with something that can understand? There is nothing else that we can use?
No, and once you start thinking about, a light year really isn't that far. So when you start talking about, galactic scale, intergalactic scale, when you start talking about parsecs and then megaparsecs, it's far, right? It's really, really, really far away. So 1 light second is already really far. It's 186,000 miles, right? 500 of those, which is about how far away the sun is, 500 times, I can't even really picture 186,000 miles. 500 times that? I don't know.
65.
And that's the closest star to us.
China from here.
So,
That's crazy.
yeah, the solar system is huge. The galaxy is huger. The clusters of galaxies are gigantic. The, filaments and voids are ginormous. I don't have a good way of describing distances that big. So. Questions, comments, concerns about time dilation or light contraction? So I want to go next to our Lorentz transforms. So I did some problems with these in our problem session yesterday. We'll do more tomorrow.
Tomorrow is lab.
It's going to be a dry lab. I was telling people earlier, I do not have the ability to actually take you on a field trip at speeds close to the speed of light. So instead, we're going to have to do it with a worksheet. So. We could also switch to the other frame, and all we're really doing is switching the primed for unprimed and switching the negatives to positives. yay-ish. And again, gamma is still, oh, I took it off the board, so I should return it. Because I'm lazy, I don't know if you have come to this conclusion yet, but I'm often going to define beta as V over C, and then I can write gamma as just 1 minus beta squared, under the radical, obviously. Hooray. And really what this gives me is just kind of some fraction of the speed of light, right? Okay, so let's use this to get to velocity transforms. And then I might try a mathematical example. So last time Alexis was talking about how he wants to throw eggs at me from a moving vehicle.
Did I traumatize you?
Traumatized, I don't know. That implies that I wasn't already there. When I was a kid, my best friend threw broken glass at me. I have a scar on the side of my nose.
Oh my God.
From it stuck.
You can remember him.
That was my best friend, so.
Oh. So we should be careful about your best friend.
Eggs or broken glass, I'm not sure. Depends how clean the broken glass is.
Oh my God. I remember when I was young, some people throw the frog in my face.
A living frog?
Yeah, the frog, but not the green one. The one have some spots in the skin. I don't know how to call
It's
it.
a toad.
Yeah, kind of throw that in the face. It's better than glass, you know. It's my enemy forever.
Okay, so I want to point out something here that differs from when we were talking about just Galilean velocity transforms. So when we were just talking about Galilean velocity transforms, remember if the two frames S and S prime were moving relative to each other along their x-axes, then we only saw a Galilean velocity transformation that was different between the two along the x-axis, right? But that was because in the Galilean in the Galilean transforms, t was equal to t prime, right? Here, t and t prime aren't the same. That's the family cow you gave away, right? In the past, I've described this lecture as Einstein messes with space and time, right? So since we don't necessarily agree on time intervals, and speed, average speed is distance covered over time spent. If we don't agree on distance and we don't agree on time, well, except for the speed of light, we don't agree on speeds quite as well either. And so this time, not only do we see a change in the x component of measured velocities, we also see it in the y and z components. Because that time interval disagreement still occurs. Does that work for you? Okay, so I did get time answers for you, but let's talk at the end, because I'm being slow. I want to do an example for you, and part of this may mean that space-time diagrams I may have to talk to you about tomorrow, but let's see how quickly we can get through this. So. Got 22 minutes. So we're approaching that point in the semester where
We have 6 weeks left.
it's, if I were capable of basic human emotion, I would, I'd say that I was gonna miss you guys. But,
So fraud.
but what I am capable of is not liking change, right? And so note that, you know, something close to missing you guys is I will notice that you're not here and it will be annoying. Right? So, but you know, I've been doing this long enough that I kind of know how this turns out.
I still have.
So as soon as the final is over, I get to be the S frame. We're gonna have Alexis taking off as fast as he can. He's gonna go 0.75C. Alexis gets to be the S prime frame.
Alexis going.
He's been putting up with my obnoxious attempts at humor. I don't know, can you call any of this humor? But for I think longer than most, so
I appreciate that.
Is Alexis drive a car or drive a bicycle?
I'm
I
driving a
can't-
motorcycle.
A motorcycle
That
with
almost
the
goes the
speed of
speed
light?
light. Well, it's not a car, but-
0.75 C or, okay.
Still pretty impressive.
Wow.
and Susan.
Susan is in the picture.
I was waiting to see who was going to be the other person in our. Susan is going to this. I don't know when our final is. It's I guess probably Thursday finals
Maybe
week.
just Chris. Chris is driving.
Chris and Susan are going to be driving as soon as what's it gonna be like 12:30 p.m. on the Thursday of finals week. They're going to be getting away from me as fast as possible and deleting my email from their contact list. Totally understand. So. Okay, so these are speeds as measured by Mark. And so what I want to know is how fast does Alexis see Chris and Susan moving away? So
1.65 C. Oh wait, no.
what's the problem with that?
It's not in the same direction. It's not in the opposite direction.
Also, we have a speed limit, which is C.
What?
Yeah, because C
You
is fixed.
signed the
fixed.
EULA.
Wait, you're saying the fastest
It's C.
anything can go?
It's C.
Is C.
The limit.
I didn't make you agree to it. So let's see if we can sort this out. So let's look according to Mark first. Let's see, that's going to be Alexis. has ux equal to 0.75c and uy equal to 0. Yay? And Chris and Susan have, according to Mark at least, ux equals 0 and uy equal to minus 0.9c. Yay?
Yep.
Okay, so let's use our velocity transforms. So ux prime. So what is ux for Chris and Susan as measured by Mark?
0.
0. What is V as measured by Mark?
Negative
Shouldn't be
0.9c.
positive. Why is it negative?
Because I didn't give you the other. Just flip all the minus signs and interchange the primes and unprimes. Yay? So what is V?
Negative 0.96. 9. Yes.
What are the two reference frames that are doing the measuring here? Me and Alexis, yeah? So what is V, the speed between our two reference frames? 0.75c. Yeah?
So are we talking about Alexis or Chris and Susan?
So Mark and Alexis are both measuring the speed of Chris and Susan. This is the speed of Chris and Susan as measured by Mark and also as measured by Alexis. The unprimed frame, the primed frame. Yay?
I'm a bit confused. Why is that?
So this is akin to saying there is some object here that is moving. Oh, let's call that u. So I measure u for this, but the primed frame measures u primed for this speed, right?
Correct.
So here, I'm measuring the speed of Chris and Susan to be 0.9. We want to know, what does Alexis say the speed of Chris and Susan is? We're both measuring this thing, right? This thing just happens to be Chris and Susan. Yay?
The B should be the velocity of the reference frames, right?
V is the velocity of the reference frame of the primed frame as measured by the unprimed frame.
Okay, got it. Thanks.
So 1 minus 0.75c times, what's ux?
0.
0. And so what does Alexis say is this x component of the speed of Chris and Susan?
Negative 0.75 C.
Okay, so now let's look at the y component. So uy prime is uy. What's uy according to Mark?
Negative 0.9.
Negative 0.9 c over gamma times 1 minus, what's v again? 0.75 c times what's ux? Times 0 over c squared is minus 0.9 c over gamma is, let's see, gamma here, so 0.75 squared, negative plus 1, square rooted, shift 1 over x is 1.51, is about 1.511, and so shift 1 over x times 0.9 negative is about 0.595 negative. C.
So, wait.
Yes, no, maybe so.
Why is the 0 in the top UX prime? What is that like representing? You said here,
What's this guy?
yeah, that's saying like
So-
Alexis is not moving.
So I say we're both measuring this, right?
Yeah.
So I say that Chris and Susan aren't moving in the x direction, they're moving purely in the negative y direction.
Okay.
And so ux is 0. This,
Yeah, I got the rest.
okay,
What are you dividing negative 0.9 by?
by gamma. So gamma is 1 over 1 minus v squared over c squared. What's v? 0.75 c. Yep. So this is equal to 1 over 1 minus 0.75 squared. And I got about 1.51, I think, something like that. Yay? So if I want to know u prime, well, it's going to be ux prime squared plus uy prime squared is going to be about 0.957. .958, I rounded carefully.
Is V just the speed?
V is the speed of Alexis's reference frame as measured by Mark.
Not the velocity.
Well, I'm accounting for direction with pluses and minuses.
So if he was going the other way, it would be negative?
Yep.
Okay.
So, notice this is less than C, right? Which is good news because you guys already accepted that the speed limit for any particle with mass is less than C. But let's, because I've got about 8 minutes, let's try another. So I can't draw spaceships. So this is like a space shark, right?
What if it wasn't moving perpendicularly to the car?
If it wasn't, you mean if we had, it was moving in both the X and Y?
Yeah.
Then you break it into components, right? Then this wouldn't have been 0.
Oh. Okay.
It'll still work, and you'll still get a value less than the speed of light, because you have to.
I mean,
It's
for-
built into the formulas.
But what would V be for gamma? Is it the,
What would, V is the speed of the primed reference frame, oh, you mean that the frame is moving in both the X and Y.
yeah.
Then you want to rotate your coordinate system so that that is one axis and one axis alone.
Okay.
So you want to turn that into the x-axis or the y-axis or the z-axis. I recommend turning it into the x-axis because then these equations hold. But yeah, you don't want to try this in multi-axis. That'll make it sad. So
You don't want to run out of time in the exam. Need 100%.
So let's let this space shark be traveling according to Mark, who's being burned by the space shark's thruster or whatever. Let's let this be traveling at, I don't know, 0.8 C. Yeah? He's got a flashlight. And so, how fast is this light traveling according to the space shark? 1 C?
Yeah.
Now the question is, how fast does Mark see the light from the flashlight attached to the space shark?
See as well.
But let's see if our equation, you're right, Mark has to, right? But we just saw that these velocity addition equations shuffle things around. So let's see what this does. So, as usual, I get to be the unprimed frame. So the space shark is the primed frame. Yay? And so let's go I. Well, here, let's do this in an easier way. I'm holding the flashlight. The answer works either way, but this makes the calculation just a little simpler. Let's see how fast the space shark sees the light. So now we can go directly to this, right? I'm unprimed, space shark primed. Both of these are in the x direction, so x prime for the light is, what do I say the speed of this thing is? I see it as 1 C. Minus V, what is the difference in speeds between what is the speed of the prime? It's 0.8. Divided by 1 minus, what is V? 0.8 C. What is UX? 1 C. Divided by C squared. This is, what's 1 C minus 0.8 C? 0.2 C. Divided by, what's 0.8 times 1? 0.8. So what's 0.8 C squared divided by C squared? 0.8. And so 1 minus 0.8, that is 0.2 C divided by 0.2 is equal to 1 C. If I see the thing traveling at the speed of light, everyone sees it traveling at the speed of light. It's baked into these formulae. So note that that didn't happen here, but the way that these are arranged, it will always happen here. Right? If you plug in a ux is equal to c, then everyone's going to get c for it. U prime, u double prime, everyone's going to say it's equal to c. Does that work for you guys? I'm not going to have enough time to introduce space-time diagrams today, which means that you guys will get to hear that story tomorrow. As always, you guys are awesome. Have wonderful days. Thanks for stopping by. Don't be strangers. Enjoy your days, but not so much. And I'll see you next time.